Now let's talk about constraints. What are constraints and how constraint works? And in here, I'm using this very simple scene. I have just created the box and match size, and I'm using the scatter node to scatter bunch of points. And in here to create the irregular arrangement of these points onto the scatter, I'm just not using the relax iteration, and I'm using the Voronoi fracture to fracture our geometry. And in here as you can see, we have multiple outputs. This Voronoi fracture outputs these two outputs. The first one is the geometry. I can create an a null and I can view, and by default we are actually viewing our geometry. And the second output is the constraint geometry. And if you connect this, and here you can see we have all of these edges. We have these polylines, and these are what called the constraint. So let's see how these constraints actually work. And I'm going to create an a example in here. I'm going to create an a box node, and let's visualize the box, and maybe let's move this box up so that we have some y offset. Let's add an a sphere node. I'm going to create the sphere, and let's visualize this, and I'm going to add its center, and also let's adjust its x position as well. Let's merge both of them, and I'm going to merge both of them. I want to create a unique name for both of them, and this time I'm going to manually create the name. So I'm going to add an attribute create, and I want to create the name attribute and set the name to name, and that is a string. I'm going to change this to string, and this one I'm going to say that is the box. And I'm going to duplicate this node, connect this in here, and I'm going to rename this sphere, and that is our sphere. And now we should see these two unique, and here you can see we have string and we have two unique names. And now we can add the RBD configure, and RBD configure will look for the name and pack our geometry. And right now we have this weird visualization for the box, and that is because of the normals. So let's go into the box, and we need to add the vertex normal. And now because we have normals, we shouldn't see the weird visualization. Let's check, and here you can see we have our visualization good. And now we are ready to simulate. So in here I'm going to add the RBD bullet solver node, and I'm going to connect this in here. Let's go into the bullet solver. Maybe let's add the ground plane, because you know that it will just fall down forever. So let's add the ground plane and let's hit play. And here you can see we have these two objects, and they are simulating independently. I can go into the box. Maybe let's add a rotation in here. I'm going to add some y and some z rotation, and let's hit play. And here you can see both of they are simulating independently. We have these two separate RBD objects. And now let's say I want to make a connection between them. I want to constrain these two geometries together. I want the box geometry to be connected with the sphere. And I can connect these two geometry with the constraints. And to create the constraints, we need to create the polyline between them. And let's see how we can do that. And right now we have these two geometries, and we are packing them with the RBD configure node. And after that we have these 2 points and 2 pack primitive to actually connect these 2 points, because after we have packed our geometry, we are only working with points. If I were to add the extract all points, let me add this, you know that we are working with just these 2 points. So to connect these 2 points, we have a node called connect adjacent pieces. So if you type connect, and here we have the connect adjacent pieces. Let's add this, and I'm going to connect this because these are the points I want to connect. Let's view this. Nothing is happening, and that is because we need to go into the parameter. We have the search radius, so it is only looking for the radius in the 0.1, and right now the distance between 2 is greater than 0.1, so we just need to increase the search radius to look for more, and here you can see after we have reached the threshold, I'm going to just increase this to all the way up to 10. It's not going to hurt us anyway. So let's increase the radius, and here you can see we are connecting these 2 points with this polyline. If I enable my point, now we have point number 0 and 1, we have this primitive. If I were to middle mouse button, this primitive has all of these attributes that we have onto these points. If I were to middle mouse button, we have bounds, density and name, and we still have all of these attributes. If I were to middle mouse button, and here you can see we are still keeping all of these attributes, which means this point 0 will have a value of box because point 0 is in a box, and the second point is sphere, so the second point should store the name value of sphere. I can check, go into the geometry spreadsheet, and here you can see the first point we have box and the second we have the sphere. So we are retaining the name attribute and we have line between them. I can say that now I can use this line to set the constraint, and I can do so by adding the RBD constraint property node. So let's add an RBD constraint property, RBD constraint properties, and let's add this. And it has 3 inputs. The first one is for the geometry, but right now we are just working with the constraint. I'm just going to skip this parameter. I'm going to just connect this middle because the middle one is the constraint. Let's view this, and here we have the constraint. What this constraint property node will do, it will just create some attributes, and it will create a constraint name attribute. Constraint name, we are creating the glue constraint. All of these attributes, this RBD constraint name attribute that this node is creating, all of these attributes, they are understandable by our this RBD bullet solver. And here you can see we have the input for the constraint. I'm going to just move this onto this side, and here we have the option for the constraint, which means we can connect this in here because that is the output that will output the constraint. Now we are using the constraint, so we have these attributes. We have the constraint name. If we have the glue, which means the RBD bullet solver will say, okay, so these 2 objects are connected with the glue constraint. On to the constraint, sorry, let me enable the constraint properties. We also have some other type of constraint. We have the hard constraint, we have the soft constraint. To change this to soft, it will just change the name to soft, and this bullet solver will know that, okay, so now we have the soft constraint relationship. I'm going to change this to glue. We have the strength value, and if I were to middle mouse button, and here you can see we have these primitive attribute. We have the constraint name and impulse half-life and all of these strength attribute that we can define from here. We can play around with these parameters. This bullet solver will look for these points that are available onto our this polyline. To actually view this point, we need to add an null and visualize this middle. And here you can see we have these 2 points, and it will look for these 2 points, and it says, okay, point 0 is referring to the box, and here you can see we have the box. This constraint is referring to box, and the second point, it is referring to sphere, this sphere. And in between them we have a connection, and the connection is the glue connection because we are saying glue, and it is a primitive attribute. So now we should have a relationship in between them. So we need to go back onto the very first frame. Let's go back. Here you can see if I zoom in, I can see the constraint on the bullet solver itself. I have the line that is going through, which means that our constraint has been imported. And now if I hit play, and here you can see both of these, our geometry has been connected together, and we are gluing them together. It is a glue constraint, and it can also be broken. I can go into the RBD constraint, and I just need to lower down the strength value. And if I were to lower the strength value to 1 and hit play, and here you can see because of the impact is harder than strength of 1, the constraint has been broken. Right now they're staying together, and now the constraint has been broken. I can change the strength. Maybe let's change this to 5 and hit play, and it's still breaking. I'm going to change this to 15 and hit play, still breaking. Let's keep adjusting this to 100. Okay, I think I need to just keep playing around. Okay, now it's breaking always. Okay, now it's not breaking, and I think it's actually hitting pretty hard. That is why we need the more strength value. But you know that these constraints can be broken if the force is greater than their glue strength. We have the other constraint type. I can change this to soft, which means that we have the soft constraint relationship. And right now, here you can see we have this with the soft constraint, they are first colliding together. And that is because of the rest length. If I go into the RBD constraint, and that is our constraint geometry, and if I were to middle mouse button, and here you can see we do not have our rest length attribute. And to actually make the rest length attribute, we can go into the connect adjacent and we have the length attribute. Let's enable this, and it will create the rest length that will store the length of this line. So the soft constraint needs the rest length to know that how far these objects are placed apart. Because we do not have the rest length, let me escape to cancel this. Because we do not have rest length, if I were to disable this, if the rest length is not present, this bullet solver will use the rest length as an A0. If the rest length is 0, which means that they are trying to pull together. And to actually keep their distance, I need to go into the connect adjacent and enable the rest length, and it will just store the length. And now we should see these constraints accurately. And here you can see, now we have the soft constraint relationship between them, and I can create my own manual rest length. So after the connect adjacent pieces, maybe let's add an attribute create node, and I'm going to connect this in here, and I want to create a floating, and it should be on the primitive level, because you know all of these attributes must be on the primitive, not on the point level. So let's go into the attribute create, and I'm going to change the class to primitive. I'm going to just copy this name rest length. Let's copy this, and let's go into the attribute create, and onto the name I'm going to paste this. Let's not use the length attribute in here because we are creating this ourselves with the attribute create, and right now its value is 0, and which means we should see the same effect. All of these will try to snap together because the rest length. Let's maybe adjust the strength. We can adjust the strength by playing around with the stiffness value. So let's increase the stiffness so that we do not have this breaking effect. And here you can see, now they are trying to match their 0 position because of the rest length, and we have the forces fighting together. Both of them are fighting together. I can go into the rest length. I can say, okay, so you are 5 units apart, and now they will try to push them apart to keep the 5 unit length. And if I were to hit play, and here you can see, by default they are too close, and when they simulate, and it says okay, so it should be 5 unit apart, and let's hit play, and it's doing that. I can go into the rest length, and I can lower this value down to 1, and let's hit play, and now they are trying to keep their 1 unit length. That is the basics of how this constraint works. And now let's see of the Voronoi fracture. This Voronoi fracture node is creating the constraint for us. If I were to view the constraint geometry, and here you can see, because we are working with lot more points, we are working with lot more connected pieces of geometry. And here you can see, if I just select this, go into the primitive, and here you can see we have many pieces. And this constraint, we are connecting all of these pieces together. So all of these lines, they are just trying, these lines has been drawn and they're going through all of these pieces. And if I were to lower down the number of particles, we should see less lines. And here you can see, because we have less connected pieces of scattered geometry or this fractured geometry, we are creating a polyline. These points are connected together. We have the name attribute. If I were to middle mouse button, and here you can see we have the name, and this name, if I go onto the point, and this name is storing that this point number 1, point 0, it is referring to piece 0, and its second point has been connected to piece 1, and piece 1 is connected to 2 and 3 and 4, and all of these pieces are now connected together, and that is why we have this connected mesh. And which means I can increase the number of these points to create more fracture. Now that we have constraint, let's import them in our simulation. First, I'm going to create the RBD bullet solver in here and connect this. And right now, let's enable the ground plane by going on to the collision, and let's add the ground plane. And right now it is falling. I can import my glue constraint. And first we need some properties in here onto the glue constraint, because right now we do not have the glue constraint primitive properties. If I were to middle mouse button, and here you can see we do have the rest length, but we do not have any information that is required by the bullet solver. And to actually add this, we need the RBD configure constraint properties node. So let's add an RBD constraint property. Let's add this. We need to connect the geometry, and it is not required. You can actually use this like so. Connect this, and it will also work. But we can actually connect this in between, and what that will do, it will just pass through our geometry. And that way we can make our network clean. All of these first input, this geometry, it is just going to pass through. And if I were to view this, and here you can see we have our fracture pieces, connect this, we have the same geometry. We have the constraint, and we have this, it is going to pass through them. But we can define the properties. We are creating the glue constraint, and we have the strength. And now we need to pack this, so I'm going to add the RBD configure node, and it has all of the same inputs, which means I can just connect this, and it will also just pass through all of our geometry and constraints. Let's go into the bullet solver, and this configure is going to pack our geometry. And now, because we have glue constraint, now our wall is not falling because they are now glued together. I can go into the constraint properties, I can lower down the strength value, and let's hit play. Let's keep lowering this strength value down. I'm going to just maybe increase this to 100, and here you can see we have the fracturing happening. I'm going to increase the strength. Maybe let's introduce a collider, and same thing, I'm going to add a sphere as a collider. I'm going to use the primitive sphere. Let me template this geometry, and let me adjust its center. Sorry, we need to adjust its Z. And also I'm going to lower down the uniform scale, move this a bit up. We need to create the attribute, because by default we are using this piece prefix. I can either add my own prefix, let's say add a wall, and now which means I can add the RBD configure, and it will pack our geometry and it will work. So I can add a merge node, and now we need to merge both of our geometry. I want to merge this geometry and this geometry, and now that is our geometry, and we do not have constraints, so that is just empty. Let's go into the bullet solver and hit play, and right now it is falling down due to gravity. But what I can do, I can add a initial velocity onto my sphere. And to actually add the initial velocity, we can add the point velocity node in here, because all of the point velocities, point attributes will going to be used by this bullet solver. So in here I'm going to use the point velocity. What this point velocity node will do, it will create the V attribute, and here you can see we have the V, and that is used for velocity. And if the V is present, this bullet solver will use this as an initial velocity. And onto the point velocity, I'm going to, right now it says compute from deformation, I'm going to say set to value. I want this to move onto my z-axis. If I take a look at this, my origin known, and here you can see I want to add the velocity on the z onto the minus z. I'm going to start with -1. So we have some initial velocity. And now if we go into the bullet solver, and it should move. And here as you can see, it is moving. And right now, I think my sphere is too big. I'm going to go into the sphere and let's lower down its scale. Let's hit play again. And right now the -1 velocity is too low. So I can go in here and I can increase this to -3. Now we will have higher velocity. I can change this to -6. And here as you can see, now we have our wall and it is falling. Let me untemplate this. Let's go into the RBD constraint properties and let's lower down the strength, because right now, because we have very high strength, all of our pieces are glued together and glue constraints are not being broken. So let's go into the strength and let's lower this value down and let's hit play. And it's still not breaking. I'm going to lower this value down even further. Okay, let's keep lowering this value down. I'm going to, maybe let's change this to 100 and let's hit play. And now here you can see it is breaking. And maybe let's also go into the point velocity. I'm going to also increase the velocity scale. I'm going to, let's give a very high initial velocity and let's hit play. And there you go. Now this sphere is breaking this wall. Maybe now we can increase the glue constraint. This strength, I'm going to increase this to, let's say, value of 300 and let's hit play. And here as you can see, we have a higher strength value. So these are the constraints, and that's how you can create constraints.